Today, let's look at the aluminum extrusions, attachments, and methods that I use to make designs out of this stuff. These storage racks are designed out of the 30mm variant of this extrusion from Automation Direct, and that's my favorite place to order them. And then when it comes to the 20mm spec, which I also carry, this one is probably less than half of the price. It is available on Amazon and all kinds of marketplaces now because many small 3D printers are made out of this. You're looking at the most common nut types that you'll find for extrusions, and the top row are the ones I use the most. Slide in is pretty straightforward. It holds its position inside of that extrusion, at least along this axis, and keeps the hole aligned in the center. But it also will slide out if you tilt your extrusion, and you cannot insert this after you've covered up the ends of an extrusion using other brackets. The drop-in nut solves that problem because it's narrow along this direction, and then it turns when you're tightening it up, and it will basically begin to grip as it's pulled up off the floor of the extrusion. Of course, this one is the hardest to keep it positioned after you've assembled. This ball spring nut is the fanciest one, and you can insert that anywhere you like, and then you can kind of wobble it into position. It takes a little effort, but it also holds itself vertically and keeps its position. So if you have like an array of shelves, then you're not going to lose track of these. Very advantageous, but it is definitely more expensive by a significant margin compared with the others. These stamped nuts you can identify these by their stamping manufacturing process, and pretty brilliant as far as the simplest manufacturing method, but they're becoming less popular, I think, compared to the others, and you might not even find them at your supplier anymore. When I see one of these, I'm pretty sure that it's going to be an inch spec instead of a millimeters spec nut, so I just keep them away. These components are anodized, and so anodizing can come in lots of different colors, but the ordinary gray is the most common and the most affordable. And I usually choose gray just because all of the suppliers are going to be offering accessories that come in a regular aluminum color or gray anodized color. And you can note that it's easy to put a scratch in this using any steel that rubs against here is going to put a scratch in the surface, and of course it's more apparent on the black. And when it comes to plastics and rubber accessories for these types of extrusions, then you come back to black as the most common option, sometimes the only option. When it comes to cutting this extrusion, I have found reliable results just using an ordinary wood saw and a wood blade. So I'm making a miter cut here, and before I cut this, I applied some wax to that blade, which is simple and affordable, and it very much helps the result on the cleanliness of the cut, as well as accumulating aluminum on your blade. That can cause trouble. It's better if you can avoid that in particular. The most repeatable method I've found is to include the piece of wax together with the aluminum while you cut, so that the blade teeth can continue to be recoated as you go. When you cut the material using a regular wood blade and a miter saw, then you can often get something like this. And the problem that causes this ugly cut is that you get localized melting. And you can see that some particles are getting smeared, and some of them are getting stuck because some bits of aluminum get captured on the blade teeth and then get carried around in a circle and just smushed. And you're smushing the part up in half instead of cutting. When you add a wax to the blade right before your cut, then you can get something like this. This is a thin sliver that's looking a lot better and almost like the factory cut. Here's a chunk of the paraffin wax that I'm using, which I got from the grocery store actually, just for a couple of bucks for several pieces of this. They come in blocks for grocery, but I bet this is nearly the same formulation as any low-cost simple wax like they use on snowboards, or they use it in surfboards and just pretty much anything you have lying around. I bet that a crayon even would do the job, a Crayola crayon. You can also cut magnesium this way, which is very challenging to get a clean cut on. And you can see the factory cut looking like this, and cutting it with a regular wood saw, circular saw, using the wax together with it gives you this gorgeous surface. When I'm marking these, this is really important just to see a high visibility mark. I'm using a pencil for the black type, and well, I guess a pencil works nice for the silver, but certainly a Sharpie is good for the silver as well. Now, pencil is pretty easy to just smear around when you try to erase it. I use acetone, and you can see it takes off the Sharpie a lot quicker than it takes off the pencil. I don't have a reliable way to get pencil marks all the way off of this stuff. You should note that all of the models that I have found are insulated at the surface, and so this anodizing is a ceramic, very thin coating, but it's also pretty hard. And so I would not try to rely on this to be an insulator, but if you need to use it as a conductor, then you're going to have to scuff that surface. You can see that's true even for the gray ones, and on the cut faces you have continuity. 0.3 ohms. When you go shopping for these things, be careful because there are two main types, and you might not notice because they're advertised with most of the same keywords. The ones that are called V-groove or something like that, they have this chamfer on the edge before the groove. And those are specifically designed for certain kits that have wheels rolling along there. And those are pretty cool kits, but not as compatible for most wide ranges of things. So for example, if you download my brackets that I've designed for 2020 extrusion, they're gonna fit fairly nice on the ordinary ones and not as nice on the V-groove, because that profile is just not quite the same. I have not seen such, at least it's not common to have a V-groove on your 30mm extrusion. I use this for structural things that I actually want to bear loads, and I use this when I just need to get basically components of an assembly positioned in place. And it is valuable simply for its accuracy. When you take a measurement on its length, you know that its thicknesses and widths and total stack ups will be exactly as you have in a CAD model. In general, for 2020, we're using the M5 fasteners. For 3030, we're using the M6 fasteners. And remaining is this kit exclusively for extrusion projects. Now that means that 2/3 of the components that we get for these projects are benefiting all other kinds of prototyping projects. First, you have the structural corner brackets. If you could only have one type of component to connect all of your parts, then I would choose this style. You have 20 millimeters in width for the first style, and the 30mm in width for my 3030 extrusions. And then you'll notice also that these holes, usually, they're always cast aluminum parts. These are the most affordable corners. Cast aluminum parts, and they have a hole that will accommodate a few different sizes of threaded fastener. Okay, but also you should note when you're looking for consistency that both of these components are sold in high volumes on Amazon, etc. And you have, of course, more strength from the larger one. The difference is this will not protrude. If you need to mate your two beams in a non-ordinary way, like this configuration is not typical because these parts have the tabs. They're designed to always mount in one plane, where you're making one plane out of your multiple beams. For the 3030 variation of this bracket, the ones that I have gotten in stock are always overhanging there. And of course, you could file that down if you really need to. The aluminum is very soft. It will take filing quite easily. And so, and in some occasions, I do mount them in this crossways. And you can simply take a hand file and remove those tabs pretty easily. When it comes to alignment, those tabs help get the general alignment correct, but until your fastener is really tightened down, then it's still going to be possible to misalign. So you can reduce this misalignment maybe half of the way by adding another bracket, but that's a lot of cost, and strength-wise, usually for almost any region of a chassis, one bracket will do the trick. And then you need to take your T assembly, like as in this one, lay it flat on the ground, loosen those just a tad, make sure it's all planar, and then tighten it up again. That's actually one of the utilities of my ceramic table right here. It's to have a space that's not occupied, that I can lay down parts and guarantee flatness. The next kind of corner bracket that is maybe second most common is this interior corner bracket. You should note that it is not symmetric. In this direction, you have a continuous metal, and in this direction, you have a gap. That's because they're designed to not fit this way and only fit this way. And so you have to do further disassembly if you want to swap or rearrange these. And it's easier to lose these set screws because they will always have a set screw, and that fastener will have a smaller tool always than the corresponding ordinary fastener. So this is less preferred in my mind. You're looking at the set screw for the 3030 version and the 2020 version. And I've got a flat tip on the set screw here, and the small one has a pointed tip. And the one that I like is neither one. Here's why. When you use this screw, then the only way that you can actually achieve a tightness is going to be actually gouging that aluminum. So right now is when it basically stopped. And if I reinsert and then I turn it further, now I can feel snugness, but only because this bracket actually has an indentation on it now. And so it's going to bite in. And if you want to eliminate a very small gap, let's say you tighten things down and you're right here and you have to move it here, then suddenly you're going to have various little dots in your extrusion that cause this to get lost or slip back out of place. It's good to keep in mind how a machine screw works. You have a clamping region, such as from this surface to this surface right here. And in that region, the screw behaves as a spring. Then by stretching that spring region is what allows the screw to get gradually tighter. When you use this set screw, there is no place for it to elongate, and it is simply in compression, making it go from loose to fully tight very quickly. Here's an example use case where we wanted the extra clearance, and so on the bottom side I've used the regular angle brackets that gives some strength, and then in the top corner here I wanted space to insert more of these screw holders, and that will be coming up probably pretty frequently. So this one I switched the type of bracket out. And you'll also notice that if some component is not bearing a lot of load, then you can certainly choose if you just want one bracket here instead of pairing them up. I wanted to draw attention to the fact that you don't usually need a second bracket on almost any configuration. We have a cantilever setup that I just estimated, okay, what can this tolerate with the minimal jointing? But we're using the best strength configuration for the fasteners. So I'll tell you about those. And basically we have 15 pounds here being hung from 15 centimeters. Okay, so here are the numbers. We've got the torque on the screw noted here, and then I'll show you how those screws are configured. But it's 6 kilograms of force downward on there. And so we don't need to worry about that bottom bracket. Just understand that if we can treat these two components as one part, then we're going to have this tension here at the top, and we're going to have compression at the bottom, and we should support the whole system at the location that has the tension, because that's where the strength of this screw will be put into action. This is the formula that makes my joint strong enough. In our case, we choose the large screw. Even though it's possible to use M5 fasteners, we use M6 for this 30-30. It has the large head, and so that's a large bearing surface on the bracket. We're using a large area on the type of nut and not using, for example, one of these. And then there's a tool and screw match so that we can have a large preload. And so in this case, I chose specifically the Phillips 3 size head that's going to match this Phillips 3 size screw, even though we could get away with using the Phillips 2 on this. And finally, no gaps. And so that means I can't have a gap in here when I begin to load this. It needs to be all snugged up before I preload the screws. What does 60 inch-pounds look like? Well, it's effectively as strong as I can turn this size of a tool with just my wrist and no extra help. That is stronger than you could get with any stick-style tool, unless you're some kind of Hulk guy. Yeah, I can't quite get that removed with just a screwdriver. Now, regarding cutting these things at angles, you can certainly cut at any angle that you want. You can pair this up like a frame. And the advantage here is that I find this is a little bit more structurally solid compared with when I've assembled them in this configuration. And if you do a good planning, you can do this type of method without consuming extra material, because you can put the reverse cut on your next member. So these 45 degrees always, you don't need to be chopping triangles out of your parts. Also, remember to double check your measurements. When you're adding a panel in, it's easy to forget. You need to add a little bit of length for this to seat into the groove. And so for a 20 millimeter size groove, you'll get about 7 millimeters extra width on my panel here, needed on both sides. And for the 30-30, you would need about 9 millimeters extra. And of course, you can trim that down a little bit for clearance. You can also make designs where you've placed the corners on the outside of a frame, and that effectively will also change your dimensions. Compared with the same lengths of these beams, if I move this to the inside corner, then I'm going to have to I'll have an empty spot here, and I'll be sliding this 20 millimeters to the left. And so in total, for this to be changed, gives me an extra 1 beam width on the long dimension and 1 beam width on the wide dimension. If you want to add a fastener at the end of an extrusion, then they have a convenient hole that you can use, but the hole is not threaded, so you will need to tap this yourself. This is an example of a tap that you can quickly add on your drill. Okay, and the 2020 size extrusion, I'm using the M6 size fastener because M5 is too small to engage threads in this hole. And for the 30-30, it's an M8 size fastener. And that looks like this just for comparison. We have M8 and M6 next to the 2020 rail. They do manufacture components like this 3-way connector, so that gives you the ability to make a square corner. But again, I don't use them very often, firstly because of these set screws. It's not as strong as using the 90-degree connectors. They cost quite a bit more, and then also when you're making a chassis, so in this case we're building up this test rig, and it has 2 frames of this type, and then these frames are always going to be made so that I can attach something. And then when you go to attach something, you can ask, does that something have its own structural integrity? In this case, it's this steel din rail, which is plenty strong enough to hold what we need it to hold. And so that becomes the structure that bonds these two vertical frames. Now, if you can survive with the strength of DIN rail, in this case, we can afford to put several of these horizontal DIN rails for the same price of adding, let's say, 2 aluminum 30-30 beams. And so that's marvelous. If you were to put 2 horizontals made of 30-30 in this case, then you have to match up the cut length very, very accurately, within a millimeter if you want to have this assembled with no gaps. But when you do it with DIN rail, you have the chance to loosen these up just a little bit and slide and make this thing adjusted however you need. If you cut the DIN rail a little bit too long, then you can squash these 2 horizontal frames to the right size, and you can file down the DIN rail that's longer than the others. Also, this is extremely easy to cut. We just use this hand lever cutting machine with no powered manual cutting, and it's quite accurate. This here is the most common mistake that I see people encounter using these extrusions. It's a screw has been driven in too far, and it's contacting the bottom floor of this groove. And so that usually happens when the assembly has components with a reasonable thickness, like this fastener. And then after they move to a region where they're clamping something thinner, then suddenly the same screw length becomes too long. So you can see in this assembly, we still have a gap, but if I clamp something very thin right here, instead of this, 4 or 5 millimeters thick aluminum, now I need to drop down to a smaller screw. This one is 12 millimeters, and I build the most equipment with the 12 millimeter, and the next most common I would use is 10 millimeters in length. And you can see that I always buy the Phillips head with a wide head on them, because that means I can clamp more things without needing to worry about a washer. This aluminum, you can see that if the head was much smaller, then we're just pinching a tiny bit of that. One edge could slip into the groove and things can more easily become misaligned, or we could just squash the actual aluminum on the edge of the bolt head. Once you start working with assemblies, it's easy to lose track of which fastener was which length, and so you can also countermeasure this issue by having on hand some thick washers that can add that height and lift that screw up off of the bottom of the groove. A lot of sellers also offer these end caps. They're good for covering up sharp edges, making things look a little bit more elegant, but I found that they're usually not worth the cost, and the cross compatibility is not good. When you have any variations from one supplier to another on the type of extrusion profile, then the cap is really depending on having its own specific matching profile. And so I'll countermeasure this usually by just adding some hot glue on the faces that make contact, like this. The points of 2 of those bubbles, I might add hot glue here and here, and then those will contact against this flat aluminum. Then it's still removable. When I want to take it off later, I can just yank at it. Honestly, even when they fit, they're just not really a good design, because the same friction which holds it in place comes from these very small interference grooves, the bosses along the edge, that make interference with the hull, and that's the same stuff that gets kind of carved away when you install it once or twice. And so it's not a super reliable part by any of the designs I've found online. There are lots more cool things you can do with the extrusions, like you can add LED light strips into there pretty easily, and they fit nice. They're self-retaining. You can purchase this rubber strip, and it's going to seal off maybe dust and contaminants, or I like to use it as a grip surface or a compression surface that's going to mean if you set something down like this assembly, then it's not going to scratch your table. So that helps prevent scratching. An alternative I used was this cork that comes in a big sheet, 1/8 inch or 1/4 inch thick, that you can just stick to there. Either way, these are removable. I found out that there's loads of these pegboard designated hooks that also will fit into those tabs. So we have, it kind of slides into place, and then you can fasten it down with one fastener, and then we can adjust the location of these anywhere we want. And here's another example where we really benefit from the adjustability of this. So now we're choosing to have a wire wrap that is appropriate for whichever kind of wire and cord you want to include. These steel handy boxes can be found for only $2 or $3 at Lowe's or Home Depot, anywhere in the US. It's USA made. And then once you can attach these, where the fasteners give you a perfect little slot to attach them using the exact same M6 fasteners. You have really nice durable ways to hook up electronics and lots more, since I've continued to publish components and designs that show you how to just grab more off-the-shelf parts, 3D print elements if you want, and then we can connect anything. A whole bunch more details. I guess I could put it in another video if this video has a lot of interest. Oh yeah, I made some assemblies with wheels. You can sometimes find off-the-shelf wheels that are designated to fit on these extrusions. However, none of them are very, cost competitive and good performance at the same time. And so I wasn't pleased with many of those. Although you can work with this, you may need to bore out the holes, etc. It starts to get custom. And my recommendation is to go download one of my brackets. So this example is a 3D printable bracket, and it costs even less than most of the wheels that you can purchase. You can install any of these equally sized wheels that are off-the-shelf components for rollerblades, and it fits on here with just 2 fasteners. And then this one can be adjusted pretty easily. If you've got Solidworks, you can modify this to fit any other kind of wheel and still maintain the mechanical integrity. I designed a few other load-bearing brackets that are all free and open source and very inexpensive to assemble, just a few fasteners involved. And so this comes with details and photos, instructions on GrabCAD. Also this one here. And the reason you might want to go with this, specifically, you might get what you need out of a bracket like this, a hinge like this, is if you need to adjust a custom setup and have this distance, you can't customize that with a design off the shelf, but you can customize it with this. And then you can have, you can increase the hole size if you need more strength. You can just double up the hole positions. And that was the purpose of publishing these, is because unlike the off-the-shelf parts, this has infinite number of variations, and you don't have to re-engineer it. It's just about making small adjustments to that model. Just in case you have Solidworks, this is an awesome shortcut for extrusions. Generating a cut list of all of your extrusion parts without bothering to make an assembly and define every single mate and handle a folder full of multiple components. And so this is the shortcut to use SolidWorks to your advantage. We're choosing to be in one plane specifically to start with, generate this 3D sketch, make a square, add a caddy corner line, and then we're going to make that line to be centered on the center of your origin, as well as change it to be construction geometry for both of these lines. Add a dimension to the first line, 250 millimeters, and then I'm selecting the bottom line to set it equal as a constraint to the vertical line. So now we're nearly fully constrained. Blue lines means it's not fully constrained. I'm going to choose one of these lines and then set it along the y-axis, x-axis, sorry. Now for the lines in this plane, we're going to add center points so that we have points with which to begin the lines when we move to the other plane. When I tilt my own view of this model, then SolidWorks basically estimates which direction this 3D line is going to protrude, and then it indicates that for you with a little bit of bounding boxes. So we can draw this a little bit crooked, and it's still going to fix it for us whenever we choose the constraint for that line. Then we can right click and we can set the directions of the vertical lines and the horizontal line, and all we have left to do is add a dimension to tell how tall this tower is, and it's going to be 300 millimeters. This is the complete frame that we are going to convert into our extrusion assembly, but it'll all be made with weldments. So you go to the weldments tab, and this should be included in most of the ordinary SolidWorks packages. It's not an extra add-in. We choose the weldment to be added and then choose structural member. We have group 1 that we will first single click on each segment that we want to be made into the chassis. And you can see the selection that we made that's defining the profile, that 3030. It comes from a custom tab. That comes from a folder that I created. I'll show you how it's done. And then the version 5 is the most cleaned up profile I made. I'll upload that. And the configurations inside that file correspond to this choice. The selections below on the menu, below the group, are the configuration choices that you have for making these extrusions join together, such as miter. Notice here it automatically added the 45-degree angles and adjusted the lengths however they need to be so that each member meets each other seamlessly. Now the cut list area of your feature tree show each individual component, each cut that you'll need to be making, and when they're identical, they're falling under one group. Now we're going to add one more group by selecting the base lines, and then it will treat those lines as a group together that should be mitered together. For this example, I will add one more change and increase the gap between the miter joints by 1 millimeter. So perhaps that gives you play to work with in your assembly. And you can notice how adding this group means we needed more clearance against the vertical group, and it has readjusted those lengths so that nothing is interfering. And this is just overall saving loads of back of the envelope math. I imagine that the other softwares also have a function like this, weldments, that SolidWorks has, and this is by far just the easiest way to get your cut list defined and even to just have imagery of the model, how you want it to look. I made 5 attempts to generate the cleanest, simplest library feature part, and then I'll post this as a link, and it'll need to go in the directory you're looking at here in SolidWorks Data, Weldment Profiles. You can drag and drop that in there, and it'll show up in the menu that I displayed earlier. Okay, I better wrap it up there. If you have questions specifically about the extrusion stuff, then if I get a bunch of those in the comments, then I can scoop them all up and maybe make another video to cover all that. It's really just a question of what people need to advance their projects. And if you need help with the SolidWorks design for a bracket or a device to enhance extrusion possibilities, then reach out on my Discord. It's linked all in my bio. Thanks, everyone.